All right, so section 7.5 is about solving systems and the different possible outcomes for solving a system. So systems of equations are either going to have one solution, no solution, or infinitely many solutions. So they're either going to intersect for one, they're going to be parallel for no solutions, or the lines will be right on top of each other, and there'll be an infinite number of solutions. Looking at the graph makes it easy to determine how many there are, but we can also find out how many there are by solving algebraically. When a true statement happens and the variables disappear, there are going to be infinite solutions, and when the variables disappear and it's a false statement, there will be no solutions. So let's try one right here. So we have our system of equations, negative x plus 2y equals negative 2, and 3x minus 6y equals 6. Again, which method would I choose here? I think either one would be nice. We said that it would be good to use the substitution method when one of the variables has a negative 1 or a positive 1, but I might even just use the addition method here. To use the addition method, I'm going to multiply the top equation by 3. And when I do that, you'll see that the x's are now equal in magnitude and opposite in sign. When I add those equations now, I'm going to get the variables on the left are all going to drop off. The x's are gone and the y's are gone. We get a 0. And our statement here is 0 equals 0. When that happens, that's when we know that there are infinitely many solutions, meaning that if we graph these, the lines would be right on top of each other. Here's another example, and I would definitely choose substitution here, and I would solve the y in the second equation, and I would plug and chug. When I do that, I'm going to get a situation where all the x's go away, and I'm left with the statement negative 24 equals 10. Well, that's not a true statement, so we now know that there's no solution to this problem. What does that mean? It means that the lines are parallel.